Right, ladies and gents, so we started our work looking at radicals and trying to simplify them. I thought maybe I didn't go at it quite in the right way, so I'm kind of starting with some other ones, and I've put a link on Teams to the website that these examples refer to. So once we've been through these examples, you can go on Teams and you can do those questions, get a bit of feedback. So I think we've got two sides. Let's go through. Okay, let's go through these examples. So we're simplifying radicals. I remember talking yesterday about when we try and simplify a radical, we're trying to remove anything that can be taken outside of the square roots, if possible, but we're not trying to turn things into decimals and having to round them and that kind of thing. Right? I think my mistake was that exercise in the book wasn't quite where I thought we were at, so I'm going to do these examples, and this is probably, I think, a better place for you guys to start. We all got the bit of paper? Okay. All right, let's go through them then. Right, so the square root of 18, right, is it the square root of a square number? No. No. Therefore, if I were to do that on a calculator, what kind of answer would I get? That's not a third, I'll get a decimal. It is a third. It would be a decimal. It would be a decimal that is infinite and non-repeating. The name of that would be, and what number?
Illogical.
It is recurring. It's not illogical. That's closer to what I'm thinking. It's actually irrational. Good. Right? So because it's a decimal, it goes on forever. It's an irrational number. That means if we were to convert it into a decimal, we would be having to round the answer. And as soon as I have to round an answer, I've reduced the accuracy. Good. Right? So we want to leave it in surd or radical form as much as we can, but we are going to try and take anything out of it. So we went through a few rules yesterday, right? Just to remind you what we were looking at. The rules that we had were, rule 1 is, remind me?
Squaring a square root gets you back to where you already
Squaring a square root basically gets you back to where you were. Rule 2. Ollie?
Making, instead of putting it on one square root, separating it.
Yeah, so this is one that we're going to really use today a lot of, which is the square root of two numbers that multiply together. You can actually separate them into two square roots. And the reason why that's useful, look, the square root of 4 can actually be changed to 2, because the square root of 4 is a square number. All right? Okay. You're going to tell me the 3?
Yeah.
Go for it.
Doesn't matter if you separate with fractions, as long as the numbers are the same, the answer is the same.
Yeah. Same idea with the multiplication, division. If you've got a fraction within a square root, you can separate it into two square roots in the division. So we're using those 3 basic rules. We went through a few examples, but I think these ones might be a little bit better. So these are ones that came up when I clicked the link. They're going to be different, but what I've done is I've picked 3 examples from each of the first 4 levels. So when you click on the link in a bit, you're going to be looking at these examples. So this will be level 1, the next lot will be level 2, and so on. Does that make sense? Okay. The square root of 18 can be simplified by doing the following. Well, does anyone know already? No one wants to give it a guess? No? Okay, you're estimating it, which is fine. What is she right, by the way? Is it approximately 4.3, do you think?
Yeah.
Yeah. Square root of 16 is useful, so this is a little bit more. So I'm not asking for that, I'm asking to keep it in exact form. So what I'm going to use is the rule that says I can split this into factors. What I'm looking for is one of those factors to be a square number. What are the square numbers?
1, 2, 4, 9.
2?
1, 4, 9.
Okay. Why is 1 a square number that I'm not going to be using?
Because it's 1.
It's just going to be 1. It doesn't help me at all. Alright, so I just end up with the square root of 18 again. But the next one, like 4 or 9, or they could be useful. You've got, I think you want 2 times 9. And what I'm going to do, just so that it's something we can follow up on, I'm actually going to write the square number first. Alright? So I've got the square root of 9 times 2. So that's using that rule where we can split that number, and then I can then use that rule which says if I can do that, I can separate them. Like that. So now the focus for me is on this, because anywhere I can get rid of a square root I will. So the square root of 9 is 3. So I can rewrite this as 3 multiplied by, but when we're doing this kind of stuff we don't need the multiply symbol. It's going to be 3 times the square root of 2. 3 root 2. Alright, so now I've gone from one radical, I've taken out a non-irrational, so a rational component to it. So this part is the rational part, and this part is the irrational. Now the fact that there's an irrational part to it at all means the whole thing is irrational, but I do have a rational part of 3, and I have the irrational part of root 2, but I have simplified the irrational part as much as I can. Okay. Got the idea?
Yeah.
What about the next one then? Now you might need your calculators if your times tables are not amazing. What do we try and divide by to find the factors? Is it worth trying to divide it by 7, for instance? No. So which numbers should we try and divide by?
Numbers that you can already tell that it's a factor.
Well, which factors am I interested in?
Square one.
The square ones. So, no point dividing it by 7 because 7's not a square. I might as well start by trying to divide by the square numbers. 245, because it ends in a 5, suggests that which numbers is going to divide by?
5 and
5, but 5's not a square number, so 25. Should we try 25? Does it work?
No.
No? Okay. Anything else then?
It gets 49.
So let's try dividing by some of the others. So you've tried 49, yeah?
No. Well, you can actually. If you divide by 49, then you get 5, I believe.
Okay. So if we try and divide by 5, we get 49. That is a square number. All right. So should we do that as 49 multiplied by 5? That breaks up to the square root of 49 multiplied by the square root of 5. What does that end up with? Jai, do you know? This is where having your times tables, your square numbers sorted. So square root of 5, we're going to leave that. It's the square root of 49, which is? What multiplied by itself makes 49? 7. This would be 7. So this one's 7 here. So we've got 7 root 5. last one again then. Let's split it. Let's try the square numbers. 147 is in. But let's try, you can divide by 16, divide by, you tell me, you work it out. Go for it. So 49 times 3, break it into 49 times the square root of 3. And again, we end up with 7 root 3. Okay. So just for your notes, these are the level 1 questions, right, on that web page. The next ones are the level 2 questions. Okay. Now, first one, nice and easy. What is the square root of 9 multiplied by the square root of 9? Just 9. This one's nice and easy because it's like doing the square root of 9 squared. You multiply it by 7. Said that. Square root of 4 times the square root of 36 though. See Nick do it? What is it?
What?
So
Square root of 42.
2 times 6, which equals 12. That was nice and simple. Take it when you can. They're nice and easy. Third one, square root of 10 times the square root of 11.
And simplify.
Well, we can.
Well, none of the.
So it becomes the square root of. Square root of 10 is not 5. 10 is not a square number, so.
Square root of 10 times what?
Which is square root of 110, no? If neither of them are square numbers or have square root factors, that's what we can do, and that's it. You know, you've got to be aware that sometimes you've got questions that just don't, like Gordon said straight away, can't be simplified. He didn't really mean this can't be simplified because it is simpler, right? I just haven't been able to do anything other than do that multiplication. So level 2 seems like a nice and simple one. Right. Over the page, this is the level 3 stuff. So this is an interesting one. So with this one, what I suggest is you think of it as, like we were doing, I'm going to start with 6 times the square root of 8 multiplied by the square root of 2. Again, we're trying, if possible, to remove any rational parts that we can. Does root 8 have a rational part we can remove? Can I find a square number factor there? What is it? 4. Okay, so let's do 6 times the square root of 4 times, right, which is 6 times square root of 4 times the square root of 2 times, now some of you might go, I've spotted something already. What have you spotted? Gordon?
I can actually be the square root of 4 times 4.
Well, we've got 6 times, what's the square root of 4?
2.
2. What's the square root of 2 times the square root of 2? 2. So now I've got no irrational part left because of the way I've worked it. So it becomes 6 times 2 times 2, which equals 24. Look. So this irrational part, when we multiply it together, 2 irrational parts have made completely rational. Okay. I'm going to do, actually, yeah, let's do these 2. I'm going to pause, I'm going to let you have a go at this one. So I've rewritten it, I've just spaced it out, put the multiplication symbols back in, just because it might help us understand. So is there anything I can change to just a rational number at this stage?
Square root of 4.
What's the square root of 4, Aidan? 2. So I've got my 4 times this bit here, look. This bit, square root of 4, I can actually already just write as 2 times 6, right? What about the square root of 15? Can I do anything with 15 to make us, is there a square number in there? No. So unfortunately, or just because it is, that is just the square root of 15, we don't need to do anything with that. Right? Then we just need to know our times tables. 4 times 2 times 6. Well, 4 times 6 is 24. Times by the 2 is 48. So we've got 48 root 50. And the final one that I'm going to go through, I think I'll leave I'll leave the last set. I'll let you get on the website to have a go at the first 3 levels. That's probably plenty for today. But let's just have a look, because this one I thought was interesting because you might fall for the trap. Okay. What do you think? Anyone know what the idea is? What the answer would be? Okay. Yeah. So by doing that, you're not falling for the trap. So what Jai said was, let's just write it. The squaring means you multiply by itself, yeah? So it's going to be 5 times root 15 multiplied by 5 times root 15 again. All good with that? I've not done it. I mean, I could have written it as 5 root 15, another set of brackets, 5 root 15 like that. But because I'm working with it, I've spaced it out. Right, any options for this? Nick? Well, I've noticed, look, that square root 15 times the square root of 15, that's like squaring the square root again. So what does that become? 15. So I'm going to do 5 times 5 times, well, these two together just make the 15. So I highlight so you can see that. So I've got rid of all the irrational parts completely. Now I just need to do 5 times 5 times 15. Which is what? 375? We all confirm? Yeah? Everyone got the same answer? 75? Okay. How do you feel about those ones we've just done? Okay? Alright, so over to you on Teams. On the Tuesday channel, you've got this link. Click on the link. You'll see we've got level 1, got a few questions. I picked to stand in the middle, and you've got level 2 and 3. So they're the ones to focus on. Okay. It's worth you not just focusing entirely on the computer screen, but having your computer there, having your book, writing the question, writing the answer, because then you've got notes to refer to. Obviously, this computer screen, as soon as you close the computer, that disappears. You've got nothing to refer to. So have your book open, write down all the questions. Feel free, instead of having to do them all, pick a range in there, move on. You don't have to do them all, but make sure you understand.